Circuit diagram of common emitter amplifier using BJT. Experiment number 2. Components required: transistor, 4 resistors, value of 47 kilo ohm, 1.8 kilo ohm, 8.2 kilo ohm and 470 ohm. 3 capacitors, value of 0.1 microfarad, 47 microfarad and 0.1 microfarad. Circuit connections in the breadboard are made according to this circuit diagram. Transistor is connected. Okay. Now these two connections are done from base and from collector. These two connections are done now. And one more capacitor. This connection from collector is taken. Okay, from base to ground, 8.2 kilo ohm. It is connected here now. The center terminal is base terminal. It is connected to ground. This one. Okay, from emitter to ground. From emitter to ground. The first terminal, this is emitter terminal of transistor. Here the resistor is taken from that terminal and it is connected to ground. And from base through capacitor, it is connected to signal generator. Yes. From base, it is connected to signal generator. This is the signal generator we are using, which generates 2 megahertz signal generator, and the positive and negative connection of the signal generator is taken here. Negative is connected to ground, positive is connected to capacitor. Positive is connected to capacitor. Negative is connected to ground, positive is connected to capacitor. This is positive terminal of signal generator connected to capacitor, and from capacitor it is taken to the base of transistor. From emitter to ground, 47 microfarad capacitor is being connected. Emitter to ground. Okay, emitter to ground. We are making use of a power supply. We are making use of 12 volt 200 amps power supply. This is positive and this is common, connected here as per the circuit. VCC is connected to one end of a resistor and one end of one more resistor. And common is grounded. Now the circuit connections are over. Let us turn on the power supply and signal generator, and before to it we have to connect the output cables to the CRO. This is the input connection across capacitor and ground, so that we'll get what is the input waveform which is being generated by a signal generator, which is given to input of CRO. This is the input cable connected to the circuit. Okay, so wherever we have provided the connection from the signal generator, across that signal generator connection, we have connected, we have taken a wire to note the signal, how it is coming from the signal generator. Okay. The signal generator input, what we are taking is 200 millivolt. So by varying the amplitude of the signal generator and looking at the CRO, we can set the value of the signal generator. Here the signal generator channel 1. Channel 1 is where we have connected the input from the circuit to this CRO. So we have to look at the channel 1 voltage. So channel 1 is 50 millivolt. We actually need 200 millivolt as our input signal. So in the CRO, one box represent 1 volt. So if we keep the amplitude, by varying the amplitude in the signal generator, if we set it to 4 box, so 4 box means 4 volt. 4 volt into 50 millivolt, it will be 200 millivolts. So now we have, with the help of a amplitude knob in the signal generator, we have selected the input voltage to 200 millivolt. Now the channel 2 of the CRO, this is the channel 2, this is channel 1, and this is channel 2. Channel 2 of CRO is connected to the output. Output is here where we have to take out. One more is connected at one end of the capacitor. This is the connection where we have connected, which is here in the breadboard. Now we have to look for the output. We have to switch on the power supply. The output of this particular experiment, we have actually two things. One is with feedback and without feedback. We are doing it in general here. What we are doing, what we have to get the output is, initially when the frequency is less, this is frequency, the x-axis shows the frequency and the y-axis shows the gain. So initially the frequency is less, so the gain increases as the frequency is increased. The gain increases up to certain point. When it reaches this particular point, the gain remains constant. Whatever increase in frequency you provide, the gains remains constant. But after this level, even though when it has reached this level, and if you increase the frequency beyond this level, then the gain decreases. This is what we will see here. This is a signal generator. Initially we have kept it to 0.2 kilohertz now, and this is our waveform, output waveform. The above one is the input one and the below one is output one. Now we are increasing this frequency. When we increase the frequency, you can see we find the increase in frequency as well as the gain. Amplitude is being increasing. Now we are we have increased the frequency to 20 kilohertz, and this is what we are getting. We have a constant gain now. The gain is increased from level, and now it has reached to its constant level. Now even further, if we increase the frequency, now the gain will reduce. You can see the frequency is now from 20 kilohertz to 0.4 megahertz now. If we go on increasing this frequency still further, we can see the decrease in the gain. The decrease in the gain. The amplitude is being reduced. This is the experiment. Thank you.